All right, welcome. Today's lesson is on 5.4, and this is more trig graphs, but today we're going to do there are four remaining trig graphs. So tangent, secant, cosecant, and cotangent. So just to get you kind of thinking about the tangent graph first, I want you to visualize the unit circle, specifically the tangent value, since that's what we're going to graph, and remind yourself, I don't have any thetas in here, but tangent of any angle is your sine divided by your cosine, y over x. So if you took all of these sine and cosine ratios and turn them into tangent, you would get these values, right? Square root of 2 over 2 divided by square root of 2 over 2 is 1. Square root of 3 over 2 divided by 1/2 is the square root of 3, etc. But specifically looking at these, because these are just like, okay, dealing with fractions, you can handle that. Sine divided by cosine, 0 divided by 1 is 0. Now go up to pi over 2, the tangent sine divided by cosine, I'm dividing by 0, which can't happen. So that's going to be undefined. Now keep in mind, you're going to be graphing these. So how do you graph something that's undefined? That becomes an asymptote. So if it's undefined at pi over 2, that's going to happen again at 3 pi over 2, because you'll be dividing by 0 again. So you're going to get an asymptote at pi over 2, and then again at 3 pi over 2, and then again at 5 pi over 2, etc. Again, being cyclical, you're going to see these asymptotes cutting your tangent graph into pieces. These orange tangent values clearly will reflect over into second, third, and fourth quadrants. I won't talk about that because that's not the point of today's lesson. We're going to be graphing these. Okay, so if I go to the tangent graph, and I just picked out a few, again, easy coordinate x angles that would be. So if I said, again, what's the tangent of 0? Well, that's going to be 0. What's the tangent at pi over 2? That's undefined. What's the tangent at pi over 4? That was when it was 1. So just picking out some easy ones that I can graph quickly is the point of this. Again, all stemming from your unit circle. So if I plot these, like a 0, 0 is here, pi over 2 and, pi over 4 and 1, pi over 2, it becomes undefined. So when I go to pi over 2, I'm going to have an asymptote. And again, at 3 pi over 2, you're going to have an undefined. As you can imagine, if you go the opposite direction, when you go to negative pi over 2, you will have an asymptote. You probably get the idea. So in between these two asymptotes is going to be one cycle of your tangent wave. So at 0, 0, and then at pi over 4 up to 1, at negative pi over 4 down to 1. So you can kind of see that tangent, I call it a tangent wave, in between there. Okay, there's another asymptote at 3/2 pi, and there'll be another tangent cycle. So this is also cyclical. It's just obviously very different from cosine and sine because of those asymptotes chopping these into pieces. Key different, well, obviously the graph is very different, but another key difference is what's the period length? Well, this length is one cycle and then it repeats. What is that length? It's only pi and not 2 pi. So your period of your tangent graph is pi, not 2 pi. That's very different. Keep those straight. Your domain is not all real numbers because of your asymptote. So how do you state your domain? It's everything except for pi over 2 and then any integers, multiple integers of pi over 2. So pi over 2, that would be this first asymptote, times 1, pi over 2 times 2 times 3, etc., etc. And your range, you can see, is all real numbers. Probably you can see that quite well. So there is your tangent graph. And now, as you can imagine, we'll be shifting these and reflecting these and all sorts of good stuff. But before we do that, let's look at a basic cotangent graph. So now that you have tangent on the brain, you know cotangent is just completely the reciprocal. So x over y, or cosine divided by sine. So now my undefined occurs at 0 and 180. And my cotangent is 0 at pi over 2 and 3 pi over 2. So I still have asymptotes here, but they're, again, obviously different. And this is still, cotangent of this is still going to be 1, as was the tangent. The tangent values at pi over 3 and pi over 6 flip-flopped for cotangent, right? Because they're reciprocals. So because these flip-flop, you know how a tangent graph kind of had like a positive slope, a cotangent graph, because these are flip-flopping, are going to have like a negative slope. So they look, I mean, you wouldn't necessarily know if it's cotangent or tangent based on a glance. So I have these filled in again from our unit circle. So I knew cotangent is undefined at 0 and then again at pi. So I'm going to have the asymptote at 0 and then again at pi. So you can see those asymptotes dashed in. And then at pi over 2, there'll be a 0 point. And rather than like a positive sloped curve, it's going to be a negative sloped curve. So the cotangent wave looks like the tangent wave, but going the opposite direction. And then again, another asymptote at 2 pi and another cotangent cycle. So like the tangent graph, the domain is all real numbers, but you have those asymptotes that are every increment of every pi over 2 increment there. So your range is all real numbers again, and your period is still pi as well, because in between 0 and pi, that's this region here, that's 1 cycle. And then you have an asymptote, right? And then you have another asymptote at 2 pi. I know you can't see my labels there. All right, so that's tangent, cotangent. Now on to cosecant, reminding yourself cosecant is the reciprocal of sine. So sine is all the y-coordinates. So I took my y-coordinate 1/2 and I reciprocaled it. Cosecant is 2. Square root of 2 over 2, if you reciprocal that, you get the square root of 2. Square root of 3 over 2, if you reciprocal that. 1, if you reciprocal, you still get 1. How about 0 degrees? If you reciprocal 0, undefined. So all of these, what makes them so unique is they have asymptotes. So you're going to have an asymptote at 0 and 180 for cosecant. So let's take a look at the graph. So here's what I recommend for cosecant. If you lightly sketch in the sine wave, and I will get rid of this momentarily. This is clearly the sine graph, not the cosecant. But because cosecant and sine are reciprocals, if you can sketch in the sine wave and then just reciprocal everything, you're going to have the cosecant. So if you think about this 0 point, if you reciprocal that, if you reciprocal 0, you get undefined. So there's my asymptote. Okay, this 0, when I get to pi, it's 0 again. If I reciprocal that, it's going to be an asymptote. So in a nutshell, anywhere the sine hits the midline is going to be an asymptote. So asymptote, asymptote, okay, you get the idea. Now, if you think about, all you need to do is find the peaks. So all of these max and mins, if you take that and you reciprocal, well, right now it's at 1, right? Maximum at 1. If you reciprocal 1, it's still 1. If I reciprocal this minimum at -1, it's still -1. So the max and mins aren't going to change, but what's going to change is everything in between the asymptotes. So if I take this point, let's just say it's like 1/2. If I reciprocal that, that's going to be up at 2. So basically everything here going down is going to go up. Everything here is going to reciprocal, so it's going to reverse. So you're going to have essentially a bunch of little parabola pieces in there, okay? So if I unveil these, notice where this max was, still it becomes a minimum. Where this minimum on my sine wave is becomes a maximum, okay? Now I'm going to get rid of the sine wave so you can focus on, here is your cosecant graph, right? So all the mins and maxes of your cosecant graph occur at your mins and maxes of your sine wave. So that's an easy way to maybe think about those mathematically and shortcut for graphing. So again, your domain is everything except for, notice there's asymptotes in every increment of pi. Your range, be careful, is not all real numbers because there's nothing in between your max and mins here. So your range is everything from 1 to infinity and -infinity to -1. So using interval notation, right? Your period is still 2 pi because it's the reciprocal of a sine wave. And if a sine wave has a period of 2 pi, so does your cosecant. So if you go from 0 to 2 pi, this piece of graph that's going up and down, that creates one cycle. So I actually have 2 cycles graphed here. All right, last but not least, your secant. I'm going to go through this one a little more quickly. Is very much like cosecant, but you're reciprocaling your cosine. So I took all the cosines, reciprocaled them, right? If I go to the actual secant graph, knowing it's the reciprocal of cosine, okay, so I have the cosine wave sketched here, and I will get rid of that in a second. But anywhere the cosine wave hits 0, like the x-axis, those are going to create asymptotes. So I'm going to have an asymptote here. I'm going to have an asymptote here, etc. So anywhere it goes through the midline, right? So those are now all asymptotes. And then just like the cosecant graph, the secant graph also takes its max and mins right here, and they reciprocal. So now instead of this, when I hit this max here, it's going to become a min and have like a little parabola piece. This min becomes a max, little parabola piece, right? So I'll get rid of the cosine graph, and that is your secant graph. So it looks just like a cosecant graph, right? But it's not. Okay, and then again, just like cosecant, your domain is everything except for, note that the asymptotes are hitting at pi over 2, right? Range is like the cosecant graph, negative infinity to negative 1, and then 1 to infinity, and your period is also 2 pi. So this would be one cycle right here from negative pi over 2 to 3 pi over 2. And you can graph, if you wanted to graph like part of one, you certainly can. All right, so in summary, very quickly, this is just like your cosine and sine graphs. You have your vertical shift, you have an amplitude, you have a frequency, you have horizontal shift. So none of these are any different than the other day. The one thing I will stress is your period length. Okay, tangent and cotangent is a period of pi divided by k. So if k changes, your period changes based on that. Your cosecant and secant is still 2 pi over k. Please note that difference. That's the biggest difference. Well, and the graphs look way different, right? So I'm going to just go through one of each kind of quickly, starting with the tangent graph. Okay, so notice on the tangent graph, and I didn't prompt you for anything but the period, but you could certainly list stuff out. There's no horizontal shift. There's no vertical shift. The amplitude is 3. Frequency is 2. Okay, normally your period is pi, but because your frequency is 2, your period is going to be pi over 2. Okay, so now think about, you got to stop yourself and you got to think about tangent graphs. Where's tangent undefined? Tangent's undefined at pi over 2. Okay, so normally, and the period length is normally pi. So normally from pi, negative pi over 2 to positive pi over 2 is going to be my tangent cycle. Now my period length cut in half. So but there's no shifts. So now my asymptotes are going to be from negative pi over 4 to positive pi over 4. So that tangent cycle is going to get really, really narrow, right? Okay, then a tangent graph without any shifts starts at 0, 0. Okay, then because the amplitude is 3, it's not really an amplitude, it's not like a max necessarily, but from my 0, 0 to either asymptote, halfway in between, I'm going to go up 3. And then same with the other direction, halfway in between, I'm going to go down 3. Now, if this was reflected tangent, these up and down 3s would just flip-flop. And that would make my tangent wave. Okay, that's one cycle, right? If I want to toss in another cycle, here's another asymptote, pi halves of a distance, my period, toss in another cycle. All right, on to cotangent. Like tangent, the period is pi over k. So k is 1, so my period is going to be pi. Cotangent graph looks like this normally, but notice this one's reflected. So now my cotangent graph is going to reflect, and it's going to look like a tangent graph, right? Okay, so this is a normal cotangent, but we're going to reflect that. And horizontal shift to the right, pi over 2, and the vertical shift is up 2. So what I would recommend, again, thinking about your normal cotangent graph, starts at or has an asymptote at 0 and pi. Okay, and my normal middle point of a cotangent graph is at pi over 2. Okay, so asymptote here at 0 and pi. But now, so my period length didn't change, so that's great, but I have shifts. So now this point is going to go to the right pi over 2 and up 2. That's going to be right here. Both of these asymptotes at 0 and pi are also going to shift to the right. Anytime you have horizontal shift, everything, including asymptotes, shift. So now my asymptote's going to be at pi over 2 and 3 pi over 2 instead of 0 and pi. So I'm going to kind of box that in. So here's my cotangent cycle. Now again, normally cotangent does this, but it's reflected. So from my cotangent point, to this asymptote, instead of going down 2, because my amplitude is 2, it's actually going to go up 2. And then halfway between my midpoint and the other asymptote, normally it would go down or up 2, but this one's going to go down 2 because it's reflected. And you can see that cotangent cycle. So these are harder for sure. I'm just trying to give you one of each, right? Okay, secant. Now, secant's a reciprocal of what? Indeed, cosine. So off to the side here, I have, okay, let's just think about the cosine graph. So same function here and here, except I'm doing cosine instead of secant. I would also factor out the 2, remember my advice, so I can see that horizontal shift. All right, so amplitude is 4. The period is 2 pi divided by k, so that's going to be pi. Horizontal shift to the left, pi over 2, and vertical shift is down 2. You can see all of that. We talked about that yesterday with cosine graph, so that's not new. So if I graphed all of this, my shifts are from 0, 0 to the left pi over 2 and down 2. That would be my midline, you can see in green. Okay, but because it's cosine, it starts at the amplitude. So then I went up 4, and my period length is pi, so it's going to start here, end here. Halfway in between from the midline, it's going to go down 4 amplitude, and you can kind of see that cosine wave. And I'm not going to actually draw it in the cosine wave, but I'm going to use those cosine points, and I'm going to reciprocal them because it's secant. So now my 0 points become asymptotes. Oops, I didn't want to unveil that. That's okay. My 0 points here and here become asymptotes. And I can move these, right? My min and max points become min and max, but instead of going down, making a cosine wave, I'm going to flip all of those. And here are my, a couple pieces of the secant graph, right? It goes on forever, but I didn't show that. So you can see everything from here. All right, last one then, and I'm going to kind of correlate this one with your calculator. This is a cosecant graph, and remember cosecant is the reciprocal of sine. So not too much going on here except for a shift up 1. So see my midline is at 1. And then cosecant is the reciprocal of sine. So normally sine starts on, goes up, on, and down to the min, and then back on. And I should comment on the period length is 2 pi because my frequency is 1. My amplitude is 2, so you can see that amplitude distance, right, is 2. So now I'm going to reciprocal everything. So if this is cosecant, anytime I hit 0, that's going to be an asymptote. That's going to be an asymptote. That's going to be an asymptote, 0 being my midline. This max is going to create a parabolic piece here. This minimum is going to create a parabolic piece here. Okay, so if I just graph that, you can see those are my asymptotes. And then those would be my 2 branches for my cosecant graph. Okay, now if you do part B where it says solve where 2 times the cosecant plus 1 equals 4 with your graphing calculator, you could do this a lot of different ways. Okay, what I did was I just put in 2 cosecant x plus 1 equals 4, right? So I put 4 on my y2. Please note 2 cosecant x is the same as 2 divided by sine of x, right? Because they're reciprocal, so be very careful how you enter that into your calculator. I set my window, you can't really tell, but I set my window from 0 through 2 pi because that's what this restriction said. We did one similar to this yesterday. So 0 to 2 pi, and then you can see the 4 here. So there's only 2 solutions. So again, calculate the intersection. So on your graph, you can see the line y equals 4 right there. So I'm calculating these 2 intersections. And you can see the one that I calculated is 2.41. This one is 0.73, which you can't see, but you can tell from the graph either way. So again, we did this yesterday, just not in terms of a reciprocal trig function. So there you have one to give you an idea. All right, I hope you have a wonderful rest of your day.